Hello. I heard my audio wasn't the greatest last time, so hopefully this is better. It very well could not be, and it might suck, but we'll get through it. You probably hear the fan in my computer. I can't do nothing about that. But what I can do is show you how to find the vertical asymptote, horizontal asymptote, and whole of a function. So I believe this is f of x from our secant solve that we did. I know it's okay if you didn't get to this problem. This was one of like the fire difficulty, more or less. But yeah, here we have like 2x minus 4 and x minus 6 at the top, or in our numerator. We have x squared plus 4x minus 12 in our denominator. Anytime we have one of these functions where we have to find these qualities of it, we want to factor as much as we can, right? So like, I'm going to find a function that's equivalent to what I have originally, but as factored as possible. So I'm going to look at the numerator here. I see I have 2x minus 4. That can be factored more, right? 2 and 4 are both divisible by 2. So I could pull a 2 out and make that 2 times x minus 2. Oops. X minus 6, I can't do anything to that, so I'm going to leave that as an x minus 6. So this is something you might see on the test where like we have a factor that's like 2x minus 2 or 2x plus 4. Both of those are even numbers, so you can factor out that 2. Whereas with the denominator here, this x squared plus 4x minus 12, I'm going to need to use the box method to factor that. Oh, that's a really wonky box, but we'll make do. Anytime we're factoring with the box, we're not going to really have to do anything bigger than this 2 by 2 on this test. But we know that that x squared has got to be in the top left. And then negative 12 is in the bottom right. It's always the case. We have our highest exponent top left, our lowest number in the bottom right. I can't find my cursor, but okay, there it is. And I know these diagonals have to add to 4x. So let me actually change colors here. I know that these have to add to this. So then I'm looking at negative 12. What two numbers can multiply to be negative 12? Well, I could have 1 and negative 12. I could have 2 and negative 6. I could have 3 and negative 4. Or I could have negative 1 times 12, negative 2 times 6, or negative 3 times 4. So then out of all these combinations, which add up to negative or a positive 4x? Well, I know that 2 times negative 6 would add up to be a negative 4. So that's not right, but it's close. 3 plus negative 4 would be 1x. But the answer here would be this negative 2 and the 6, right? Because 6 plus negative 2 or 6 minus 2 is just 4. It doesn't matter which corner I put which number in. I can make this the negative 2x and this the 6x in the bottom left. The only time it matters is if we had like a 2x squared. That changes some things with where we're plugging in like our factors. But that's not going to really be a problem for our purposes. So I know that x times x gets me x squared. And then I need the minus 2 and the plus 6. I'm just going to erase. Right. I did this factoring in this box method because I wanted to turn this function in my numerator, or this part of my fraction, into factored form. Right. That's the whole point of me doing that box. So this x minus 2, let me choose a new color just to color code it all. X minus 2 and this x plus 6, I can write in my new denominator. So I have x minus 2 times x plus 6. So now we have our function fully factored. But now I have to actually find, what the problem's asking me to find. A vertical, horizontal asymptotes, and the whole. So the first thing I notice is that we have an x minus 2 in the top of our fraction and the bottom of our fraction. Anytime that's the case, that's going to be a whole, right? Anytime we have the same factor in the numerator and denominator, that's just our definition of a whole. So not only do those cancel out in our problem, but if I was to set x minus 2 equal to 0, just like I would any denominator, I get that x equals a positive 2. That x equals positive 2, that's not a vertical asymptote. It's a whole because it cancels out with the numerator. Anytime I'm looking for the whole of a function, it's got to cancel out in the numerator and denominator. We found that x minus 2 cancels out, and x minus 2 gives us the x value of a positive 2. So that means that our whole in this function is x equals 2. So I'm good on that. So now I have this x plus 6. Well, if I am just setting that equal to 0, I get x plus 6 equals 0, minus the 6 on both sides, I get x equals negative 6. See, that's not a whole, because there's not an x plus 6 in the numerator as well, that's just a vertical asymptote. So I have a VA, or vertical asymptote, at x equals negative 6. So then there's only one thing left to find, it's the horizontal asymptote. So anytime I want to find a horizontal asymptote, there's that separation between the bottom heavy functions and the top heavy functions, where if there's more factors in the denominator, we say that's where the horizontal asymptote is at 0. Or if there's more factors in the numerator, there is no horizontal asymptote. But I have the same amount of factors in the numerator, that's 1, 2, that I do in the denominator, 1, 2, right? So I don't have any little trick I can do for now, so I'm just going to plug in a big number, right? I'm going to, let's take a little lime green. No, that doesn't show up that well. Never mind, I lied, we're doing orange. So if I plug in a big number, let's say 100, nice, simple, right? Just so I don't have to plug in a bunch of things into my function, you know how we canceled out this x minus 2 here? Whether we include it or not in our calculation when we plug in this 100, we're going to get the same value either way. So instead of doing 2 times 100 minus 2 times 100 minus 6, all divided by 100 minus 2 times 100 plus 6, I will get the same value if I just do 2 times 100 minus 6 over 100 plus 6. Because these two factors cancel out, I don't have to worry about them in my final function. They're equivalent. The only reason those are helpful is because it tells me that there's a whole at x equals 2. So technically, I could just completely get rid of the x minus 2 for all I care. Unless you're writing your final answer for your factored function on the test, do not get rid of it. I know I'm throwing mixed signals, but for the purposes of plugging in, I don't really care about that x minus 2 right now. So I get 2 times 94 over 106. I don't really care to get a calculator, but you should get that this is pretty close to, like, I don't know, 1.9 1.95 or something. Again, I'd have no idea what that exact number is, but it's going to look like this, right? 1.9 something. And last time I checked, that's pretty close to 2. So because that's close to 2, that means my horizontal asymptote is at y equals. Oops, what happened? Anyways, y equals 2. But I'm not done for the sake of this video. Typically, that's all you're really going to have to solve for, but I do want to kind of try and take this and graph it, just so we can have a little demonstration of graphing a rational function. You're not going to have to graph anything this complicated. Probably only something that has one factor in the numerator and one factor in the denominator. But let's look at this function again. And then I'm going to have, where is it? I'm going to have this graph. It's not very detailed, but, you know, some's better than nothing, right? So I know I have a vertical asymptote at x equals -6. So I'm going to draw a little vertical asymptote. This is x equals -6. And then I have this horizontal asymptote at y equals 2. It's going to be like here. So that's y equals 2. So I know that my function's not going to touch those lines, right? That's just the definition of a vertical and horizontal asymptote. And then all I really need to know left is whether it's in this top left corner and bottom right, or if it's in this bottom left corner and the top right of my asymptotes. So I can just do that by plugging in. So when I'm graphing, I want to plug in an x value to the left and to the right of my my vertical asymptote. So since my vertical asymptote is at x equals -6 here, I'm going to plug in f of -7 and f of -5, because that's on both sides of that asymptote. So I could very well just plug this into this function, right? I could just plug it into the 2x minus 4 times the x minus 6 all over x squared plus 4x minus 12. Or, what we simplified to earlier, we could plug that into 2 times x minus 6 over x plus 6. You're going to probably see a function more like this one on your test, like that you're actually going to have to graph. Again, we had said that that 2, or the, what is it? The x minus 2's kind of cancel out, so they don't really matter, except for the fact that they gave us a hole at x equals 2. So I'm actually going to label that now. There's some hole over here. Hole at x equals 2. Wow, how magnificent. So when I plug in this -7, this -5, I know I'm jumping around quite a bit. My work ain't the cleanest. If I'm plugging in this -7, I'm just going to do 2 times -7 plus, not plus, minus 6 over -7 plus 6. That is 2 times -13 over -1. So that is equivalent to 26. If I plug in f of -5, I get 2 times -5 minus 6 over -5 plus 6. So that is equal to 2 times -11 over 1, which is -22. So on the test, you're not going to end up getting these values that are really large, right? Like, you're not going to get a 26 and a negative 22, because typically we're only working with graphs that go from like negative 10 to a positive 10, so this wouldn't really fit anywhere. But the point still comes across, right? Like when I'm plugging in a negative, oops, what is that? When I'm plugging in a negative x value of, or when I'm plugging in a value to the left of negative 6, I got a positive number. So that's going to be somewhere up here. Let me actually use a different color so it stands out more. This 26, when f is negative, or when x is negative 7, that's somewhere up here. When I plug in negative 5, so somewhere to the right of my asymptote, I get a negative 22. So at x equals negative 5, it's going to be somewhere down here. So that tells me that my graph is going to look something like this. I know it's not the prettiest. You actually won't even have to graph any holes on your function. So this like hole that I drew doesn't matter too much. It's more so just finding what x value it is. That's what really matters. But yeah, I think that's about it when it comes to finding asymptotes, finding holes, and graphing. It's all the same concept, just with different values and likely easier problems than this one. But like if you're able to do this type of problem without really any outside guidance, I'd say you'd be pretty set for this test.